Alright, in the last video we only did examples on how to find odd roots of a number. This video we're going to talk about even roots of a number. And remember, when we take an even root, we get two answers, a positive answer and a negative answer. So the question is here, find the real square roots, and that's really the key, is we're only looking for real square roots, not complex or imaginary, of the following numbers. So the first thing we need to do is we need to put the square root sign over our number. This is not a perfect square, we can see that, so we're going to factor it. And we know that 5 goes into 75. How many times? It goes into 75, or it goes into 7 one time, with 2 remaining. 5 into 25 5 times. We know that 15 is not prime, and that 5 goes into 15 3 times. So with a square root, I'm going to write the index up here. We're looking for groups of 2. So we have a group of 2 here. We're going to pull one of those 5s out, and we have a number remaining. We're going to keep that number, a square root. We're going to keep that number under our square root sign and write the square root of 3. But remember, we don't just have a positive answer, we also have the negative answer as well. So we have 2 answers here. Let's take a look at the square root of a number like this. So the first thing we're going to do is we're going to write our square root symbol. But I'm going to suggest for this one that we take a look at just the number without the decimal places, and we factor our number without decimal places. We know that 49 is a perfect square, and that it factors into 7 times 7. So we know that our answers, since we have a group of 2, is going to be 7. But it needs a decimal place, and we need to figure out the decimal place. Here this has 4 decimal places. Since we're taking a square root and we're only going to have 2 numbers being multiplied in order to get this number, we're going to have 2 decimal places in each number. So the square root of 0.0049 is going to be half the decimal places, 0.7. And since it is an even root, it's also going to be negative 0.07. How do we take the square root of a fraction? Well, I'm going to write my square root symbol. Okay, so to take the square root of a fraction, again, we're going to have 2 answers, but we can split our answers up into the square root of the numerator over the square root of the denominator. We know what the square root of 36 is. It's just 6. What is the square root of 121? We should know that as well. It is 11. Okay, so we also have 2 answers here. We have the positive version and the negative version, just like back in chapter 4. But now let's go ahead and take the square root of this number. This is going to give us something different. What did we learn in chapter 4 about taking the square root of a negative number? We know that in order to take the square root, we need to pull an I out, an imaginary number, and then this becomes positive. What are we being asked for in our question? We're only being asked for the real solutions here. This will never be a real solution because we have an I in it. Therefore, this one has no real roots. So now let's take a look at these 3 examples over here, and we're going to find the 4th roots of these numbers. So the first thing we're going to do is we're going to take the 4th root of this number, and we're going to split it up into the 4th root of 81 over the 4th root of 16. Again, the root that we're taking is even, so we have both a positive and a negative answer. I know that the 4th root of 81 is 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81, and the 4th root of 16 is 2. And because I have a positive and a negative, I'm going to write my answers like this. Alright, so now let's take the 4th root of negative 0.0625. And we learned over here for this example that if we have a negative under an even root, we need to pull an I out. And we are left with just the positive number underneath. Okay, but we are only being asked for the real roots, not the complex roots. So this is not a root. So let's take the fourth root of 48 and see what we get here. Hopefully we'll get something. We know that both 6 and 8 go into 48. And we know that 6 factors into 3 times 2. And that 8 factors into 2 times 4. 4 is still not prime, so we factor 4 into 2 times 2. We're looking for groups of 4. So we have a nice group of 4 2's here. We're going to pull one of those 2's out, and we're going to keep our 3 under our fourth root sign. And because it is a fourth root and even root, we have both a positive and a negative version of it. There you go.